Hello, welcome to this tutorial series of design patterns. Today we are going to look into decorator pattern. It is a type of structural pattern. I am Balasubramanian. So let us look into the definition of structural pattern. Structural pattern helps easing the software design by identifying the simple way to realize the relationship among entities. How do we organize the classes and put them into structure and making them more flexible? This is what structural pattern talks about: identifying the relationship, organizing them into structures so that the developed software will become more flexible. That is the goal of structural pattern. Today we are going to look into decorator pattern. It is one of the structural pattern. Let us look into the definition of decorator pattern. Decorator pattern is a structural pattern that allows behavior to be added to individual object at runtime without affecting the behavior of other objects of the same type. This definition is a little big. Let's cut the definition into parts and understand, because it is important for us to move further. Decorator pattern is a structural pattern that we know. It allows behavior to be added to individual object. How do we add behavior to an object without affecting the behavior of other objects of the same type? Consider inheritance hierarchy. For example, if there is a parent class and some of the child classes or the concrete classes inherits the parent class, and if we need to add behavior to one of these concrete classes in the inheritance hierarchy, the behavior of other classes should not be altered. So the decorator pattern talks about how do we add behavior to a particular concrete class without affecting the behavior of other concrete classes which are of the same type or in the same hierarchy. I hope this is clear. Let us, while we look into the example, we will understand it more. And it is very important for us to understand this. Decorator pattern adhere to single responsibility principle. So what is single responsibility principle? Any class which does certain function should do that function, or it should not do multiple other things. So decorator pattern adheres to this principle, which is one of the solid principle, where S is the single responsibility principle. Decorator pattern helps to combine multiple behaviors to the component being decorated. So it is a little complex definition. How can we add multiple behaviors to the component that is being decorated is what is being told in the decorator pattern. We will revisit this sentence after we look into the example. So what are the components of the decorator pattern? There is an abstract component, and there are concrete components which inherits from the abstract component. There's an abstract decorator and there's a concrete decorator. Here we need to note one point. The abstract decorator is a component and has a component. So decorator pattern has both. It adheres to is a and has a. This way of organizing the object helps us to decorate the component with multiple decorators. For example, if we have to decorate the component which is being decorated with multiple decorators, this pattern enables us to do it. So when we look into the example, this definition will become more clear. As usual, the code is available in the below link: github.com/gopalbala/GOF patterns. Let us directly go into our sample. So before we look into the code, let us look into the UML diagram of it. So we are going to look into a coffee example for this as a first, which is given in Wikipedia as well. So I've done little alterations to it and to make it easy for people to understand without deviating from the pattern. So we are going in. So suppose think this example as a coffee shop. Okay, a coffee shop is selling coffee, and when we are going into a coffee shop such as a Starbucks or Coffee Day, so they sell different types of coffee, but the base ingredient is coffee. In our side we call it as decoction, right? So when we add milk to a coffee, it becomes milk coffee. When we add milk and cream to it, it becomes creamed coffee. when we add milk, cream and chocolate to it, it becomes a chocolate creamed coffee, right? Then when we serve it chilled, it becomes chilled coffee, right? Cold coffee. So what are we doing? The basic the basic thing that we are serving is coffee, and there are different types of coffee, right? So here we are adding behavior to coffee at runtime, and without affecting the chain of other classes which are inheriting. That is the point that we are talking about. So here coffee is the component. Plain coffee is a concrete component. Coffee decorator is the one which helps to decorate the coffee with the other ingredients, right? So here coffee is the basic ingredient. We are decorating coffee with other decorators like creamed coffee, milk coffee, chocolate coffee, so whatever we talk about. So we are going to add functionalities to at runtime. We are going to add behaviors to the coffee so that the coffee becomes a different coffee. So that is what this decorator helps. And if we see it, as I told, this coffee decorator is a coffee because it extends from coffee, and it also has a relationship because the coffee decorator has coffee. So this enables this decorator to be decorated to enable the decorator to add multiple decorators on top of it, and then add chain of behaviors to it. That's what it is. So since I think this diagram should be very clear, so let us directly jump into the code. Show me the code. Okay, decorator. Okay, we have two examples. First, let us look into the coffee. So I have made the coffee class as an abstract class. Every coffee has ingredients which are added to it, right? So what are the ingredients is been represented as strings. We can represent, for this basic, I have just used string. So ingredients can be a list of list of objects like ingredients as well. That can be done because for this example I've just used as a string, but ingredient itself can be a complex object which has other properties, measurements as well. But for the simplicity of understanding, I've made it as a string. And a coffee has a cost associated to it, and we are going to use a double to get the cost of it. So let's go into, so this is the component, right? The coffee is an abstract component when it comes to compare this to the UML diagram. Coffee is the abstract component and plain coffee is the concrete component. So plain coffee extends coffee, which is plain coffee inherits coffee. So plain coffee is a coffee here. The is a relationship. Whenever we say is a relationship in OOAD, it means that it is an inheritance. So a constructor which is a default constructor, get cost. So the basic cost of this coffee is one unit or $1 or 1 rupee, whatever we take, right? So it has not used the currencies, specific currency as such, but assume that it is one rupee or $1. So what are the ingredients of this basic plain coffee? It contains only the decoction, which is the decoction part of it. It does not contain anything. It does not contain milk. It does not contain any other ingredients. It just contains the decoction which we got out by boiling the coffee and then getting the decoction out. Now let us look into the decorator. For example, if we need to prepare, when we come and ask, we say that we would be able to add anything to the coffee and then customize coffee in the taste that we like, right? When we say that coffee with double cream. So creamed coffee is one, and people want to add more cream to it. They will be able to add double cream coffee to it, double cream plus chocolate plus ice on top of it. So the coffee will be decorated with these kind of things, and it would be served. So the basic serving thing is coffee, which is the component, but we are going to look into the decorator part of it, right? So as I said, coffee decorator is what we're going to create, and coffee decorator extends coffee. It means coffee decorator is a coffee here, and we have a it is a composition, right? So we have coffee as a object here. So it is having this is called composition. When we look into this variable, uh, private coffee, decorated coffee. So we are going to decorate this coffee here, right? So the coffee decorator has coffee. So now this coffee decorator is a coffee and has a coffee, and that is what I've told in the slide. It, so this is okay. So if we note it here, the abstract decorator is a component and has a component. Let us directly look into it. This is the abstract decorator, which is the coffee decorator. It is a component which is coffee, and it has a component which is coffee. I think now it would be clear. So initially I have told in theory, but if we look into it in the example, then we will be able to understand it. So the coffee decorator has a constructor because it is final, right? So we are going to add behaviors to the coffee without affecting the other child classes, right? So we made this as final, and then we take in this coffee as a constructor. So what would be the cost of it? If I have to get the cost of this coffee, so whatever is the decorated coffee, get the cost of it is what we are going to say. And if we are going to get the ingredients, I'm calling decorated coffee dot get ingredients. So that is how I'm going to get the ingredients of it. Now comes the concrete decorators. So let us look into coffee with milk. So coffee with milk extends coffee decorator. So it means that coffee with milk is a coffee decorator. It takes in coffee as a parameter which is passed to the coffee decorator class, so that it can hold the decorated coffee. So when somebody asks for the price, so I can go and say that super.getCost, or even I can call the decorated coffee.getCost as well. Decorated coffee.getCost. Okay, so we can do that. I'm saying that whenever you have whenever we say has the cost, you go and get the super.getCost, which is going to be $1 only, right? Suppose that if I am going to add a different cost to it, I can say return super.getCost plus 0.75D. So I am going to add some cost to the cost which is already there, because we are adding milk to it, right? So the cost gets incremented. So coffee with milk costs little more than whatever is the coffee which we serve. So this is what it is. So what are the ingredients? So I'm going to what would be the ingredients of this coffee with milk? So it should have the parent ingredient, which is the decoction, as well as the milk. So what am I going to serve it? I am going to serve when I call get me the ingredients of this coffee, the super classes ingredients plus the current class ingredients is what I am going to do. So this coffee with milk is a coffee which contains two ingredients, which is the parent ingredient and child ingredient. So here this coffee with milk is a different instance of a coffee class, but it has little more properties. So we are adding dynamic behaviors to it, dynamically certain things to it, without touching the basic behavior of the concrete class, which component, which is coffee. So now things would be little clear. While we run it, the things becomes more clear, much more clear as well. Let us look into the other example, which is cream coffee. So what is this cream coffee? Cream coffee is a coffee which is the coffee gets decorated with the cream coffee, and what are the ingredients to it? It has the previous ingredients of the coffee plus cream added to it. So what would be the cost? Since cream is added, the cost would be the parent's cost plus the cost added to the current coffee. So that is the cost which is getting added here, right? So what were the ingredients? What the parents' ingredients plus the child's ingredients. That is what we are going to add to it. So let us look into the main class, right? So how am I going to execute it? It is very it's very, but how do we construct this object is very little important here, right? So the classes are getting called very easy. So we are instantiating a coffee, right, which is a plain coffee. That is the basic ingredient of a coffee, right? So we are instantiating coffee C equal to plain coffee. So the plain coffee is going to get decorated with milk. The plain coffee is going to get decorated with cream. So what am I saying? I'm going to say that, okay, I am having a coffee. I'm ordering a coffee with milk, and I am ordering a coffee. I'm decorating the coffee with the cream as well. So when I say go and get me the cost, it would get the cost of plain coffee. It would add milk to it. On top of it, cream is getting decorated. For the same coffee, it is getting decorated with three types of it. So let me execute this and show. I'm running this. Let it take some time. So the total cost becomes 3.85. What are the ingredients of it? The plain coffee's ingredients is decoction. On top of it, we decorated the coffee with milk. On top of it, we decorated the coffee with cream. So this way, we are able to add dynamic behaviors to the base concrete the car class without touching the class behavior to it, right? For example, if I have to, I will show you another example, which is like chocolate coffee, right? I'm going to add a new class, which is new Java class, which is CHOCOLAT, chocolate. So I'm going to add chocolate coffee. I'm adding it. Extends coffee COFF coffee decorator. So I am going to implement it. So create a constructor, control O. I'm going to override all the methods, which is get cost and get ingredients. So it is going to get the parent dot cost. Since I am adding chocolate to it, I'm going to add plus 3.0 because I'm going to charge the chocolate little more. T. What is the previous ingredients? I'm going to add this with CHOCOLAT. This coffee contains chocolate. So I've just added chocolate to the coffee. So when we go to the main class, if I'm going to add chocolate to the cream coffee, C equal to new chocolate coffee of C, and then print the cost. Let me run this. We see what is the cost. So it's the previous cost to us. If I comment this, we will come to know whether we are able to add it successfully or not. I'm running this. The previous cost is 3.85. Now chocolate cost is 3. So the total cost of the coffee should become 6.85. And it is 6.85. What are those ingredients? Previous ingredients are decoction, milk, and I've added cream to it, and I've added chocolate as a topping on top of it. So the total cost of the coffee, we are able to compute it, and we are able to get the ingredients. This is how we organize the classes in a way that we can add dynamic behaviors to a component without affecting. So did we go and change the coffee class to add a topping to it? No, we did not do. So this way we can dynamically add behaviors to the concrete class by using decorator. So here is where decorator comes into picture. This is very important. So decorator, how decorator helps to add behaviors to the component is it, because the decorator is a component and has a component. Since it has a component, I'm able to get what are those which are in the component, and I am able to inherit that, and I am able to add dynamic behaviors to it without deviating principles. So if you see what does chocolate, how it helps, how it adheres to single responsibility principle. A coffee with milk will add only milk to the coffee. It doesn't do anything. And what it does, it computes the cost. It only gives this cost, and then it adds this cost to the parent dot cost. It does not do extra behavior to it. So It adheres to the single responsibility principle, that it doesn't do any other extra thing. Although it helps to add dynamic behaviors, it doesn't deviate from the single responsibility principle. So what would be the point which we need to note when we are considering decorator pattern? There will be lot of small objects which would live at any point of time. If we have to add a coffee with skimmed milk, coffee with soy milk, coffee with high fat content milk. So there will be lot of concrete objects which would live. And suppose that if we have to take out one object, it is easy that we will be able to take out that object and remove the class. But yeah, but we need to think about it as well, right? So how do we dynamically add behavior? How do we dynamically remove behavior? So what are the use cases that we can think of in this, when we use decorator pattern? I have used decorator pattern while I am building an insurance policy. What is that insurance policy? An insurance policy contains so many covers, which is a pillion driver cover, a third party cover, a owner driver cover. Covers are which helps you to cover up certain things. Electrical accessory cover, for example, how we are insuring the electrical accessory covers means we are insuring the third the owner as well, owner who is driving the car. The co-passenger cover, which is we are insuring the co-passengers as well. We are insuring the electrical accessories as well. We are insuring the non-electrical accessories as well. So insurance is an insurance. These covers get added, and an insurance will be able to add a motor policy insurance will be able to add these covers on top of it, and then when we calculate the price, we should be able to arrive at the final price of it, saying that okay, give me the price of this insurance which has all these covers, which are all these types of insurance, right? You can so finally we will be able to get it. So I have used here, I have used it in other places as well. So decorator helps in solving these kind of problems. Yeah, thanks for your time, and if you like this video, hit the subscribe button and then subscribe to my channel. Thanks for your time.